we were talking about using GEMDAS to solve inequalities. So we want to solve inequalities by inverse operations, and we want to solve inequalities using more than one step. So here we have example 5. 22 is greater than 14 plus x. So in order to figure this out, we have to figure out what all the values of x would be that would solve this inequality. So we have to use our inverse operations. So if we don't have a sign in front of a constant, then we understand that we assume it's positive. So here we're going to subtract 14 from both sides and subtract 14 from both sides. And the 14 and the 14 cancel, we're left with x. Bring down our inequality sign. And here we have 14, or 22 minus 14. So we can borrow 1 from the 2. So 12 minus 4 is 8. And 1 minus 1 is 0. So 8 is greater than x. How do we get there? That was inverse subtraction. And now we can look at graphing this. This is correct, but it's a little bit difficult to graph. So what I want to do is I want to rewrite this inequality. I want to put my variable on the left side. So I'm going to write down the x. And now I want to make sure my inequality points the right way. So the pointy side is going towards the x. So I want to make sure the pointy side still goes to the x. And then I'll write down the 8. X is less than 8. So here's 8. And I want to know what kind of circle do I draw at 8. Because there's no equal sign, I'm going to draw an open circle. And the arrow points to the left. So I'm going to draw to the left to show that all of those numbers will work to solve this inequality, will be true. Now I can look at set builder notation. This is set builder notation right here, so I can rewrite it. X is less than 8. And interval notation, I want to take a look and say, I know I have the top side is 8. There's nothing bigger than 8. But what's my bottom side? What's the lowest value it can have? And that arrow means it's going to negative infinity. So when I go to write my interval notation, I start with the lowest value. The lowest value is the one that's furthest to the left. So that's going to be negative infinity. And that's going to go to 8. Now, whenever I have infinity, that's going to be a parentheses, never included. We can never count to infinity, positive or negative. And then if it's an open circle, that means that I'm going to use a parenthesis to finish out my interval notation. Then we can look at example 6. And here we have n divided by 17 is greater than or equal to negative 6. So the first thing we have to do is we have to multiply both sides by 17 to get rid of the 17 in the denominator. So I'm going to multiply by 17, and I'm going to multiply by 17. And the reason that we did that is there's an understood 1 here. So what that does is it cancels the 17 in the numerator and the 17 in the denominator. And we're left with just n is greater than or equal to, and then we have to do a little math here. 6 times 7 is 42, and 6 times 10 is 60. So when we add those together, we get 102. So negative 102. And then how did we get there? Well, that was inverse multiplication. And then we can graph it. We have the variable on the left, so we're all set there. So n is greater than or equal to negative 102, and that is the set builder notation is n is greater than or equal to negative 102. So I can draw negative 102 on my graph. Is it an open or closed dot? It's going to be a closed dot because it has the equal sign underneath. And then I'm drawing to the right. In the interval, we know that we want to have two. We want to have the top side and the bottom side. The bottom side is negative 102. The top side is represented by this arrow, so that's going to be positive infinity. So my interval goes from negative 102 to positive infinity. Positive infinity is not included because it never is. But then we look at the dot over negative 102, and that's the equal to sign. So that one will be included with a bracket.